Hi everyone, I'm Paul Knox-Johnston from Haven Knox-Johnston. Welcome to the latest webinar, latest in our series of webinars, of the From the Helm series. We've covered all sorts of topics in the past, from sailing around Britain to living on a narrowboat with YouTubers Fran and Rich, from floating our boat, and you can watch all of them on our YouTube channel if any of them sort of take your fancy. But today we're addressing a slightly different subject. Today we're talking about lithium batteries for your boat. How this webinar is going to work is we're going to run it with some short presentations to start, so we can sort of start by covering the basics, which will then move on to some discussions, and then we'll have a Q&A session towards the end as well. And the aim of the webinar is twofold. What we're trying to do is we're trying to address some of the myths about lithium batteries, and we're trying to go through the basics of what a good system looks like. And whilst we are predominantly aiming this presentation at lithium batteries on boats, it's safe to say that some of the learnings from this session can be applied to camper vans as well as general life. So without further ado, we've got a panel that covers all sides of the discussions, from a marine surveyor who can tell us what he sees in practice, good and bad, to a technical director who can dispel the myths and tell us what we should be doing, to a fire investigator who investigates when it all goes wrong, whether it's lithium or batteries or not. But it's probably better if I let them introduce yourselves. So over to you, Ben, Paul, Peter, please introduce yourselves. Very short introduction.
Yeah, good evening, everyone, and thanks for joining this. Yes, huge subject, as Paul said. I've been surveying boats for over 20 years, been in the industry since I was 7, and come from just using one 12-volt battery to start an engine and run all the lights on my little Vivacity yacht, all the way up to where we are now, with all sorts of strange systems and wonderful ways of charging stuff.
Peter?
Okay, well, good evening, everybody. Thanks for joining us. So 42 years ago today, I joined the London Fire Brigade. So I've been in the industry for 42 years. Over 30 years with the London Fire Brigade. I ended up as a borough commander for the City of London, the group manager for the Fire and Arson Investigation Group. And we just come up to 12 years with Fire Investigations UK, so we think we're doing something right. We investigate all thermal events and explosions. So if it catches fire or gets hot enough, we'll forensically investigate it for you.
And Paul?
Yeah, hi, good evening, everybody. I'm Paul Bailey. I'm the Technical Director at Marine Energy Systems. I've worked in the marine industry pretty much all my working life, really, and worked for major boat builders where I've had all sorts of roles, from actually building boats, selling them, testing them, development. So yeah, a lifetime, really. And now we work predominantly with boat builders and OEMs and our trade partners to provide technical products and support for them. That includes power generation and power storage, things like thrusters and stabilizers, electric propulsion, pretty much all things electrical, really.
Fantastic. And thank you very much, all of you, for giving your time to help us out here on this webinar this evening. And as I'm sure everybody on the call will say, we've got quite a panel of expertise here with a lot of years experience. So okay, so now we've met the panel, let's get into the subject. First thing I think we need to do is we need to understand what a lithium battery is, where they've come from, and where this whole debate has started. And for that, I'm going to hand you over to Paul.
Thanks, Paul. Okay, so a good starting point, really, and I think something that comes up really often is what's the difference between lithium ion and lithium iron? And so to start us off, I think it's worth covering that. But lithium batteries themselves, they've been in use since the 70s. It's probably more accurate to say they've been in commercial use since the early 90s. So they were developed in the 70s. So it is a relatively recent and really what we're calling state-of-the-art power source. And where they're used, we're used to seeing them now in electric vehicles and energy storage systems, huge wind and solar farms on houses. So that has really prompted and promoted the evolution of the technology that's led to what is now, I think it's safe to say, a reliable battery. There are multiple different chemistries in the lithium-ion range, and I think just to talk a bit about those will help us to understand what we're using and where we're going, really. So we have, as I say, a range. There are 6 main chemistries used in lithium-ion. Okay, lithium cobalt oxide. That's the one that we probably encounter the most often. There's that's lithium cobalt oxide, lithium manganese oxide, and nickel manganese oxide, and nickel cobalt aluminium oxide. Then there's right at the top, lithium titanate. All these abbreviations, by the way, are sort of a bit more industry standard than the scientific annotations. And the last in the group is lithium iron phosphate, and that's the one I think we're going to talk the most about tonight, and the properties thereof. So in terms of where they're used for us, we've, of course, on board boats, we have to include the fact that there are things on our boats that may not be to do directly with the boat themselves, but in terms of boat systems, we see them for use in standard DC systems. So that's the everyday components on the boat, pumps and lights and navigation equipment, that sort of thing. Refrigeration, there's a photograph there of a fridge, but really what that's to denote is where we're using lithium very broadly is to provide power at mains voltage via inverters, and that's really where they come into their own. So we can get 230 volt, 50 hertz supply from lithium. And of course, for vessel propulsion, and that's showing there just a low voltage system, and we'll talk a little bit more about that. In terms of other applications, these photos indicate really where else we see these things. Toys, as we call them, scooters, that sort of thing. Mobile phones, laptops, tablets, cameras, that sort of stuff, tools, and waterborne toys. And they're all relevant.
And Paul, I'm sorry, Paul, so the other application, or the toys as they might be sort of going, which kind of the lithium battery do they generally tend to use?
Well, there's a bit of a list. So it's a good question. So we're saying for boat systems, we're using predominantly lithium iron, well, only lithium iron phosphate, and the lithium cobalt oxide. That's the one at the top. That's the one that we encounter, I think, most often these days, although there are changes. They're in our mobile phones, and the others are used in various places, cars, you know, that sort of thing. So we're focused really on lithium iron phosphate, but it's all about energy density, really. With things like lithium cobalt oxide, very high energy density, but much less stable. And this is where we start to look at things relating to the stuff that hits the news with fires. So yeah, it's quite a broad range of applications.
And the chemistry and safety parameters are all completely different within these batteries?
Well, they all share the fact that they have lithium, but yes, the lithium is combined with different elements to give different characteristics for different uses.
Okay, and I know our audience, I know there's going to be a majority of the audience who are going to hear about boat systems, and it sounds like we need to sort of divert ourselves off into the other applications just to sort of cover those off at the moment, because it looks as though that And from a lot of sort of anecdotal evidence, it's the other applications where they're a lot of the stories we're seeing in the press are coming from. They've obviously Ben, Peter, can I bring you in on this point, please? Because it sounds like that, as I say, the other applications are the ones that are causing quite a lot of problems. It's the ones we hear about in the news. I mean, is this in your experience too?
A lot of the stuff that I get involved with, you'll see the headlines in the local newspapers more than you will see on the main news. And certainly from my personal experience of doing insurance claims, not just for yourself, but for other insurance companies, it is what I call the toys are the problem for me personally on many boats that I go and look at, where something's been left on charge. I've even had a battery pack left on a bed that caught fire for some strange reason. We've also got things like the bike. Thank you. I had this actually happen a couple of years ago before that fatal accident happened in the flat where the children and the wife tragically died. And it's the same thing. This battery was left on charge. It's a rechargeable battery that came out of a bike on a narrow boat. And it was just the grace of God that the people on board were able to get off at the other end of the boat. And it's one of the things that Peter and I have discussed in the past is the fact that, and I think most of the fire brigades now, aren't they, Peter, are saying about having exit plans and thinking about when you put stuff on charge and the rest of it. But this battery caused significant damage, and luckily it didn't take anyone with it at the time of the incident, but it so easily could have been from the extent of the fire.
Yeah, what we're finding on and the fires we're investigating is particularly with the bikes, it's the retrofits. People aren't buying a complete kit that, or buying a properly designed and manufactured electric bike. They're buying a battery from somewhere, they're buying a drive system from somewhere else and a motor from somewhere else. And I think Paul will probably cover later that the battery management system is really paramount to the battery safety from the charging, so it doesn't overcharge, undercharge. But there's a reason why the London Underground and London Transport, and I'm sure lots of other places, are banning the e-scooters. And today I was on coming up from the city on the Underground, and there was a public announcement reminding people that these toys are not allowed on the Underground. And the reason they've taken that step is the scooters, the batteries are low down underneath the standing platform, and they get impact damage, which are not good for lithium batteries, whatever their chemistry. And so that they've banned them. And the fatal fires we've heard are often the people, as Ben rightly say, they charge them up and they'll put them in the hallway on the escape route. And when they go wrong very quickly, and people can't get out. But I'm seeing more and more boat owners around marinas using scooters to nip around the marina. And they might have an absolutely top class lithium system installed on their vessel, but then they sling this perhaps cheap electric scooter onto their vessel and charge it up. And the other thing I found quickly is that a couple of super yachts I've done, if you can't find the calls, blame the lithium battery. So they get bad press, like electric vehicles. You mentioned EV on a ro-ro container vessel, and it's obviously them, like Luton Airport, you know, oh, it was an EV. Well, it wasn't an EV. So we need to get the facts really and just get the balance right. But there's things that we'll discuss that you can hopefully take steps to prevent something going wrong on your vessel.
I think one of the things with it, Peter, we've discussed in the past, and certainly from your own lectures and I've attended, is the fact that, and Paul's just mentioned this, is the sheer amount of power rammed into a battery, isn't there? And when it goes wrong, it really goes wrong really quickly, and it's difficult to put out. And you've got a video, haven't you? I
was going to say at that moment, what a good segue into the video that Peter sent us. So
I did a double-decker electric bus fire that had over 24,000 batteries in it. And it only took 2 to go wrong. This has got 1,000 sparklers, and it's a similar thing. Once it starts, you can't put it. I'd love to have done this, claimed credit for this. I might try it one day, but
Are we meant to try? Are we meant to do that Blue Peter thing? Please don't try this at home.
Definitely don't try this at home.
But we just see that, you know, the chain reaction, it takes just one of them to get going. This is a little bit over the top, but it certainly shows you how quickly a reaction can develop. And
But I think what's beautiful about this, Peter, was the fact that it just explains that chain reaction, and that's exactly what happens in the battery, because all the cells are individually wrapped, aren't they? But once one of the cells is damaged, it then will spread itself really quickly across.
Well, and we've seen them on the YouTube videos and so on, where you've got one pack will go like this double-decker bus. You get one pack of nearly 5,000 batteries start burning, and then it seems to subside, and then the next pack get going, and you get this stop-start effect as the packs do develop. So and trying to put it out is a completely different subject.
So the thing is, I mean, obviously these things happen, and but when it does go wrong, what can you do?
When it goes wrong, you get out as quickly as you can, because you really, that's why they shouldn't be on escape routes, as Ben has said. You know, the fire investigated, had they hadn't got a secondary escape route, they'd have been trapped. So you really mustn't store these on escape routes. And these batteries, some of them aren't that difficult to become detached. You know, put them in a battery charging bag, which are fireproof, and you put those in a safe place. But to mitigate the risk, you really need to take ownership of the battery and check it. Chris Clark, I believe, is on tonight, and myself, we were CAA qualified drone pilots, and to keep that license, we had to keep a battery log. So for one aircraft, we had 4 batteries. We numbered them. We had to register the state of charge before flight, state of charge after flight, how long we were flying for, and just keep a simple log like that. And then it jumps out of you then when one of them starts to go wrong, and then you can do something about it. But, you know, it's human nature to just try and get every last bit of energy out of the battery. And if it's not performing as good as it was last week or last month, do we want to spend a lot of money on just replacing it when it's actually still working? And that's the problem. It's human nature, really. It's understandable, but
some of the toys I've seen recently that turned up. I mean, I'm very lucky that I have a couple of weeks every year out in the Ionian, and one of my friends, who may be watching or not, I don't know, he bought his son one of these superb underwater zoomy things. I have no idea what you call them. Second generation. Yeah. But the battery that comes out of it, and this comes back to what Peter's saying about different technologies are used to make some of these things. So it's not the people who are making that bob, or whatever you want to call it. They're not making the battery, they're buying the battery of someone else, and then they're buying bits and pieces off. So the whole assembly is completely not paired. And there's no clear instructions on how to charge it. And he was charging it on the rear deck of his powerboat, and the deck was wet. I could see the steam coming off the deck, and it's like, guys, that battery is red hot as it's being stowed on your deck, right by your exit door. You know, if that had caught fire, there was no way they would have got out of their boat. And you know, only last week we've had another powerboat catch fire, and the speed of it is less than 2 minutes from the time of ignition to the point where the boat is well alight. So you've really got to be careful where you're putting these, especially on motorboats, where normally you've only got the rear exits. So I really, for me, the whole point of this webinar is to make people safe, and hopefully with Paul and Peter's advice, we can make at least your installation safe and make you think more about the toys, because it's the toys that I think are one of the bigger problems.
Just want to cover one thing off, which you guys have, which you've mentioned, is charging bags. Could you kind of just, I personally, I've heard of them because we've discussed them in the past, but there may be a lot of people who don't know they exist.
Yeah, they're like made out of, you know, like plumber's mats that you put behind a pipe when you're soldering it to prevent it setting fire to your kitchen units. It's a sealed bag. It's got a very strong Velcro seal on it, and you just pop the battery in. They're all different sizes, pop the battery in, have the connecting lead coming out of the bag through the Velcro, and if anything goes wrong, then it's contained within the bag.
That sounds like a really useful thing for everybody to sort of pick up from this. Is if you've got toys or anything on the boat, then there is a sort of something you can use to sort of as an extra safety blanket in a way, I suppose, is a phrase I'd use. But yeah, we've just put up this slide here about what to remember about, you know, it's all pretty common sense. I mean, don't leave anything charging by an exit. I mean, it's logical. As what you said earlier is, you know, when it goes, get out. It's got to be rule number one, I think.
Yeah.
I think mainly that's because you can't actually extinguish them with a normal dry powder fire extinguisher, which is the 9 times out of 10 what you've got on the boat.
So yeah, so it's I mean, that's got to be one of the prime messages we're going to come out of this is basically if it starts, just get out as fast as you can, because that sounds like rule one, I think, is what we're going to call it. But it all boils down to sort of early detection at the end of the day. As I say, don't attempt to fight the fire, just get out. I've got to be honest, this is, I mean, I go to sleep at night, my phone is plugged in on the bedside table. I'm thinking I might not do that anymore as I move forward. So yeah, so that's been a really fascinating sort of insight for me, as you know, because we do these things, we have all these things charging. There's hundreds of things charging around me as I speak right now, but it's all about being safe and making sure that we're keeping an eye on things. And if you do start to see anything smoking, run to the wind.
It's just good habits, Paul, really, you know, just developing those good habits. And anyone who's seen my Christmas tree fire, like Ben has, will realise that, you know, if you see a flame in a real Christmas tree, don't try and tackle it, get out. And, you know, a picture paints 1,000 words.
I've seen that video. That is really quite disturbing as well. Yeah, how quickly that went down. Thank you very much. I mean, that was a little bit. I thought what we'd do is we'd cover the sort of other things and we'd sort of run through those. And now what I want to sort of bring us back to is the boat systems and, you know, how a professionally fitted system can be done, how it's done, what you should consider, and all that sort of side of things. So I'm going to hand back over to Paul now, who is going to sort of tell us more about the batteries that are using boat systems and why you should choose that chemistry and whatever is over any other. So, Paul.
Thank you. Yeah, I mean, that's all really interesting stuff, and it's all I guess it's the newsworthy stuff, and it's really what has driven up in some cases, in a lot of cases actually, people's reluctance to make the move to lithium ion. And so I think it's worth us taking a look at what is it about lithium iron phosphate over the other lithium ion technologies that makes it attractive to us for use in boats. And at the top of the list there, low energy density, really that is in comparison to some of the other lithium ion technologies, not all of them. Some of them we leave out because they don't have the longevity, or they don't necessarily have the ability to provide enough power. But the fact is that lithium iron phosphate is right at the bottom of the list in the lithium ion range when it comes to energy density. And the important thing there is, of course, that what that really means is that one of the things that affects the temperature of the battery is the rate at which you take the power out and into it. So if you're using lower energy density, it follows that you get less thermal activity. It's pretty straightforward, really. And in their own right, they have good structural stability. Structural stability is really important. And the thing about lithium iron phosphate is its component parts are essentially incombustible at higher temperatures. So that's not quite the same as as a fire being caused by the energy in the battery, but the materials themselves are not combustible. It's very clear that they are very much less prone to thermal runaway than the other lithium-ion technologies. And it follows that if they are exposed to high temperatures or hazardous events, like short circuit or impact damage, they're very much less likely to catch fire or even explode. And so that's really what makes lithium iron phosphate the most common choice for us when we're looking to replace lead acid technology in boats. The pros and cons, I think, is something for us to consider when we look at lithium iron phosphate against lead acid. What are the benefits for us, and why is there a surge toward the desire to make the change? Well, they have, I guess, at the top of the list, extended life cycle capability. Life cycle is taking the battery from fully charged to a point somewhere close to discharged and back up again. That's considered as a cycle. And we get a great deal more of cycles from lithium iron phosphate than we do from all of the lead acid technologies. Unparalleled safety in terms of battery technology. If you've got a lot of energy stored in a battery, whether it's lead acid, alkaline, or lithium, it's stored energy, and that energy is what it is. It's the same in every type of battery. So even high quality AGM batteries, you have to give consideration to the fact that they have stored energy, and you have to apply common sense and keep it safe.
Sorry, Paul. Sorry, Paul. I'm just going to jump in there. Can we just AGM? Can you just break that out?
Yeah, of course. Sorry, it's a lead acid technology, very common now. It's really in quite a big way almost taken over from standard wet lead acid. Absorbed glass mats. Essentially, the electrolyte in AGM batteries is sort of contained in pouches and kept in contact with the plates, and it's got lots of benefits, not least of which is it gives lots of power. So yeah, I think we see them pretty much everywhere now. We have a very high thermal runaway threshold. Thermal runaway is the events that Ben and Peter have been referring to. It's where the internal temperature of a battery, or more accurately, battery cell, gets to a point where it starts to combust. And once it starts, as Peter said, it's unstoppable. And the threshold for that event in lithium iron phosphate is well over 500 degrees. So in that respect, it is the safest. High energy density, again, we're making the comparison to lead acid, significantly higher weight for weight and by volume. Significantly lighter, much lighter in fact. If you've not had the opportunity to get out of them and chuck them around, you'll see probably something like a 40 kilogram AGM battery is probably around 15 kilograms for the equivalent in lithium iron phosphate. This one sounds slightly controversial, but it's cheaper in kilowatt hour terms over its lifetime. We'll talk a little bit more about that in a minute. Can discharge up to 100%. More commonly, 80% is the threshold. In some cases, 90%. But the very top end batteries can be discharged to their rated maximum in terms of their rated power. In terms of disadvantages, the performance of these batteries can suffer at low temperatures. In fact, does suffer. The problem with lithium iron phosphate is when you get down below 10, but really more below 5 degrees C, it's very difficult to recharge them, and they can be permanently damaged if you try to charge them when they're that cold. Essentially, what happens is you start to plate, coat the internal components with lithium, which makes it useless. They've got a high upfront cost, so the initial cost of them is quite high. Again, we'll look at that a little more. And in most cases, there's a requirement to change the standard charging system. I think it's worth mentioning at this point, there are quite recent developments with what are being called, I believe, extension batteries, hybrid extension batteries. These are batteries that have now been developed that you can directly connect them to a lead acid battery. So effectively, hence the name, effectively extending the function of the lead acid battery. They don't, on the face of it, require any changes to your standard charging system. But the fact is they do have the charging system changes incorporated into the battery. Because they're still lithium iron phosphate, so they still need the same charging profiles as the standard types. We haven't had a great deal to do with them. They're quite new, and I think they're probably a whole separate discussion. But they seem to be a really good idea for I think DIY installation, because it's a one shot. You can get them in. Essentially, the standard battery remains and functions as it always does, but it doesn't get discharged. The discharging, if you like, takes place with the lithium battery, and it's got a bit of clever kit inside that allows that to happen, and I think it's partly controllable via apps. There isn't a great deal in terms of information relating to them being installed in boats. Most of the manufacturers of them, I think a couple of German manufacturers, they talk about them on their website, but if you read their installation manuals, there's actually no mention of boats. So there's a bit to look into there, really. As I say, haven't had a great deal to do with them as yet, but I'm really interested. They look exciting, and it's a nice development to look at in the future.
And Paul, one of the benefits on the list was rapid charging. I mean, how rapid is rapid? I mean,
significantly more so. Different batteries have different ratings, but I think we've seen some questions relating to rates of discharge. So when you're looking to provide a lot of power for things like bow thrusters and windlasses, you need lots of energy very quickly, and with good quality lithium iron phosphate, typically you can get 1 to 200 amps continuous current from them, and it is possible to charge them at that rate. But generally speaking, the sorts of batteries we're talking about, you're looking at recharging at around 60 amps.
Okay, and you mentioned the thermal runway being as, what was it, 500 degrees? Sorry, what? Is there a thermal runway, or is there anything like that with lead acid? Is there a similar sort of thing, or?
Not really, not in the same way, no.
Cool. Okay, so we can see there may be huge benefits to switching, but whereabouts on the boat are they used? Let's see if we can move into that sort of side of things. Okay.
Again, all of this is a very broad topic, so we're trying to snip bits off here, but essentially when we're looking at electrification on board, we're seeing this has been very much driven. There's a lot of interest in people wanting to be greener, so the applications that we're looking at and working with predominantly providing power for onboard domestic systems. The fairly obvious bit is replacing your lead acid with lithium iron phosphate to run the standard boat systems. But we're seeing a lot of interest and a lot of activity. And to be honest, I think they come into their own when you start to look at using them for use to provide power via inverters. So we're seeing a lot of that, and we're doing a lot more of that than we are with propulsion and propulsion systems. There's lots of stuff going on out there. We're working with systems under 50 volts, which is the sort of cut-off point for things like intrinsic safety. So once you go over 50 volts, you have to be aware that you're dealing with potentially dangerous voltages. And so, yeah, the high voltage systems up to 800 volts, pretty lethal. You need to make sure that you can't get at them both in the building process, but also in the maintenance and for the end user.
So we have two distinct sort of uses. I mean, switching over to the domestic systems sounds like it might be the simplest of the two, but so how is that done?
Well, so we're what we're doing quite a lot of is we're installing lithium iron phosphate batteries, if you like, alongside the standard boat domestic batteries. So the boats stay standard, and then we add battery towers or battery banks to provide power, as I say, via inverters to give us stable AC power supply. So we're able to do this to combine with standard onboard systems, such as standard engine alternators. There's been a bit of mention of that, and we're talking about modifying charging systems, and we'll look at that a little bit more in a little more detail shortly. But we're using a very high quality lithium iron phosphate battery. We install them in bespoke towers, which are compact, robust, to provide power for, as I say, inverters. And one of the big drivers with this is people want to run their boats at anchor overnight without running generators. So the generator operation is done during the day, and what we're trying to get across, and the boat builders are starting to see this now, is running generators on boats. That the generators are always matched to the maximum power required. That means that most of the time that they run partially loaded, and running a diesel engine lightly loaded is the worst thing you can do, because it causes rapid wear because of bore glazing, bore polishing, and then you start throwing fuel through the exhaust, so they're very wasteful in fuel terms. So what we advocate is the use of inverter power when you want to run quietly, and then or any other time, you know, people want to go swimming, for example, they don't want to run their generator, so you can use your lithium pack and inverter power for that. And when you run your generator, you run it to recharge the batteries. And I think the time will come in the future when that will be the norm, where charging from the generator, running the boat from the generator is a thing of the past. The generator only runs to charge the batteries, which means that it's running at its most fuel efficient. So this is where we're dropping into the more environmentally friendly. We're not getting away from using fossil fuels, but we're making the best of it. As a secondary function, of course, we can use the inverters to boost low shore power, and we're seeing that quite a lot. And of course, it's an opportunity to pull in some solar power. People leaving their boats for extended periods. Again, we quite often we're fitting a small amount of solar power for battery maintenance, a bit of battery management, if you like, whilst the boat's unattended. Yeah, and as I already said, it's a good way to use a generator more effectively in a greener way.
And so that's brilliant. And is there a difference then in what is required for electric propulsion?
Yes, there is. And the real challenge with electric propulsion is the amount of energy that is required. In smaller boats, it's not such a problem. If you're running 50 kilowatts, 60 odd horsepower or under, you can make it work. But if you want, and sailing boats, we see quite a lot of people wanting to convert and low voltage, smaller units work very well in sailing boats. The problem with boats, with bigger boats, is you've got one gear. It's not like a car. You know, how do you use that power? You know, if you need 500 or 600 horsepower, then you're going to really struggle to do that electrically for any sort of decent periods of time. So if you're looking at lithium power against diesel, I think diesel has somewhere between 80 and 100 times more energy, weight for weight, than lithium iron phosphate. So it's going to be quite hard to displace it.
So you need quite a lot of batteries to replace a diesel engine.
Yeah, that's right. So it's not that practical. Hybridization is something we're doing a bit of, not in the sense of hybrid extension batteries, but using DC generators to charge batteries that are being used to run the boat, both domestically and for propulsion. The generator only runs to recharge the batteries, because it is the big problem with using a lot of battery power. You take the power out, you've got to put it back in. So we're seeing sailing boats in particular, where people want to do extended sailing. They want to have electric power for most of the time that they operate, of course. But if they need to use, if they run out of energy in their batteries, and they need to avoid bad weather, or they've got an emergency, the DC generator can directly run the drive motor. So that's sort of, if you like, more akin to a hybrid car, and it enables people to have the opportunity to run electrically. But the big challenge on boats is regenerating the power. Got no hills to go down, and we've got no brakes.
I mean, one of the things. I mean, we're going to have quite a few people listening coming in who have, obviously, when we talk about the inland waterways, we've got canal boats which don't need massive power generation to move them along. Well, they will have that initially to get them moving, but then they generally have smaller engines anyway. So is that sort of a more achievable thing when it comes to electric propulsion?
Yes, certainly, because you're talking about relatively small amounts of energy to drive that sort of boat. However, you still have to consider, it's a bit like we're seeing with cars, I think, is that we're on a journey now to get rid of internal combustion engines. If everybody has an electric car, we need the grid, the infrastructure to support their use. And it's a bit the same with things like inland waterways. I think it's a really good thing to do is to electrify canal boats. I mean, what better way than keeping the waterways clean? But of course, if you're going to do a day's running, you're going to need to do a night's charging. So you've got to find a way to do that. And solar power works to some extent. Probably works better in countries other than the UK. But onboard generators, so you, instead of running a diesel engine to drive the boat in a not very efficient way, run a diesel engine to charge batteries in a very much more efficient way is a step in the right direction, maybe. But
yeah, because we have seen that. Sorry, Paul. We have seen that up at we've seen that sort of system introduced up at Crick Boat Show and a few games where you have, as I think you're saying, you have the electric propulsion, you have the system, but you also have the generator that's running on a faster speed that's keeping everything sort of ticking over. So I think we have seen those systems installed on the inland waterways, and they seem to be gaining popularity.
Yes, yeah, and I think we'll see more. There may be the stepping stone toward something else. Hydrogen's on the way, I guess.
One of the benefits of a narrowboat is most of them are 50 or 60 feet long, so you've got loads of places to put solar panels.
Yeah,
And
That's
I've seen quite a lot of narrowboats over the last 4 or 5 years doing very good switching over, where they've got enough power to give themselves 7 or 8 hours of actual motoring. And most narrowboat owners don't do 7 or 8 hours a day anyway. But and it's like we've got some production boats now out in the Mediterranean where they are got rid of the diesel engine and then put electric motor in for charter fleets. So it is coming, but the biggest problem is the shore hookup facilities everywhere, and the infrastructure that side. But no, you actually bang on that.
Yeah, and of course it raises all sorts of questions. Is that in that application, are we better off for putting lithium in, or are we good with good quality AGM? It's something, and it's all about, and this is the thing that we find, is that the starting point for the change to lithium, whether it's just to take out your lead acid batteries and put lithium in their place, is what's the reason for doing it? What is it that you want to achieve by doing that? It's always a starting point of the conversation, and understanding power use and power regeneration and how it applies to your own particular needs is very much at the heart of making that choice and making that decision. And if you want to go 20 years without a battery change, lithium iron phosphate, that's possible, but it's not very often we come across people that are thinking about their next battery change in 20 years' time. They're thinking more about their next boat change.
That's actually one of the things I was going to say to you, was the fact that I regularly see as a surveyor people who've spent a phenomenal amount of money on lithium battery banks, doing this, doing that, and they've only owned the boat 2 or 3 years, and they never see all that investment back at sale.
Yeah.
In the same way, and likewise, I think it was only this week or last week, and I apologise for the plug, but Theo Stocker circulated a very interesting article about is it really that green to change a diesel engine if it's got loads of life in it, just for the sake of going to the lithium for the costs of everything compared to the engine with the modern greener fuels that are coming down the line now. So it is an interesting balancing act, and I think for different people, you've got to also ask how many hours are you using the boat for, because again, you regularly see yachts where there's less, and motorboats with less than 40 or 50 hours a year on them, and I regularly get people say, "Is that really the hours on this boat?" And sometimes I've been fortunate; I've seen that boat 4 years ago, and I've actually got the clock records from the previous 4 years, and it's quite surprising how little some people use their boats. So they can invest all this money in lithium, as you've got there, the diesel against LiFePro. Sometimes it's not the sensible thing to do, but let's keep going.
No, and to be honest, it's really not at all unusual for us to, when we're talking to people, to tell them there isn't really much benefit in them changing to lithium. That's quite a common outcome, and it's they see it quite easily, really, when we get into the detail of power demand and power replenishment and all those boring things. Yeah, it's a very common outcome.
So it kind of sounds like that the electric propulsion argument is one of those ones where it sort of suits smaller boats with less power requirement. But the bigger boats, it's all going to, we're still a long way away from. But we're going to move slowly back to the domestic system. What elements of the system contribute to safety?
Well, I guess the top of the list is the battery management system, and I think everybody that has been considering or contemplating the change to lithium will, of course, come across the term battery management system, and that's the number one item in the system. In most cases, they are built into the battery, and I think it's safe to say that the best quality batteries have the best quality battery management system. If you're buying unbranded, unknown products, the most likely place for the manufacturer to cut corners is in the BMS. So the BMS really is the bit of kit that it controls the cell voltage and current flow when it's in use, and that's really important, because one of the really critical things with lithium batteries is keeping the cells in balance. That is to say that all of the cells as close to exactly the same state of charge, same voltage as is possible. So the battery management system is very instrumental in doing that. It monitors the functionality of the battery. It keeps an eye on its state of charge and tells us what that is, and it provides feedback to do that to external devices, control panels, and interface boxes and that sort of thing. And it optimizes the battery performance. It's really there to protect the battery and to protect the user. And there are other things that, if we're putting systems, and I think it's time to mention that batteries in their own right are part of a system. Even if you're looking at extension batteries, the battery, all batteries, NAGM battery is part of a system. So it's important to understand that the system that the battery is incorporated into is right as well. So we see, standard things we do: emergency shutdowns and fire alarm shutdown relays, ventilation dimensioning. Sounds a bit posh, but really what that's about is, in the event of a short circuit, that the way the battery is manufactured, it can deal with what goes on inside the battery without it being catastrophic. The battery cell balancing module, which is built into the battery as part of the BMS. We encourage, wherever possible, double pole switching. That's switching both conductors. Limiting the block sizes. That's limiting the number of batteries that you've got in direct proximity to each other within a tower or a module. T-class fuses. We use T-class fuses. T-class fuses, they're very expensive, but they are designed to operate very quickly and effectively in the event of short circuit or very, very high current. One of the things with lithium iron phosphate is the battery has pretty close to zero internal resistance. And what that means is that if it's fully charged, if it's full of energy, and you expose it to a short circuit, that energy will very rapidly come out of the battery. And as a rule of thumb, with decent quality batteries, in a short circuit situation, a lithium iron phosphate battery can provide 100 times its rated capacity in current. So that's in a 100 amp hour battery, that's 100 times that in amps. So it's a 10,000 amp event, and if you release 10,000 amps down a cable, something's going to give. And so there are other devices that we use to stop that happening, but as a backup measure, T-class fuses. A&L fuses, they're the more standard type fuse. We use those where we're putting multiple strings of batteries. So each string has its own fuse as well. And then just good working practice like insulation sleeves. Decent batteries, decent BMSs have redundancy built in. So more than one temperature sensing alarm for temperature alarms. And CAN bus communication, again, the high-end stuff. The batteries are all interconnected and provide data that we can extract, read locally, read at a distance. So these are all things that, to a greater or lesser extent, are available to include in systems that have lithium batteries built in. More commonly seen, I must say, where we're using them to provide power for inverters.
Just reiterate. You said, I think you said the battery management system, is that inherent in the battery or is it a separate thing?
It can be separate, but most commonly, most of the stuff I think that we're all going to encounter, the BMS is built into the battery.
Okay, and we've got all these batteries, we've got all this system on site. Obviously, we need to consider how we charge them. I mean, I know how there's been all this talk about charging cars, and it's like 20-minute charge. Is it the same with boats? Is it the same system, or is there a difference there?
I mean, there is a difference. I mean, what you see with a car basically is a lead. Well, the lead connects to a charging source, which is just that, but the charge control, if you like, is built into the car. So with a boat, it's a bit different. We can use standard engine alternators. There's been quite a bit of talk about the additional cost of including hardware to make the standard engine alternator work for us with the lithium battery, and that is available. They are not hideously expensive. We'll have a little bit of a look at it. PTO driven alternators, not that common, but we are seeing them now. That there's a picture of one that's an 8 kilowatt 3-phase 48 volt alternator in that case, but that's providing additional power to charge. It was needed in that case because that's a 150 kilowatt hour battery system on quite a big boat. That was installed to run pretty much all the whole boat systems. And then, of course, grid power, or shore support as we more commonly know it, or generators driving more conventional battery chargers. One of the things that we generally don't need to do if we've got relatively modern battery chargers is change the battery charger if we change to lithium. Most smart chargers, pretty much all of them I think, just have a dip switch. So if you change from one battery technology to another, you just flip the dip switch and the charger takes care of it. DC generators, we're starting to see these used more often. They're a bit like standard generators. They're just connected to clever bits of kit to charge the batteries. Generally, these are at 24 or 48 volts, and solar panels. We don't do a great deal of wind charging. It's quite useful on very small systems. Sailing boats, it's more common on. But solar power seems to have kept pace with battery technology advancement. So there's some really good stuff out there. Get quite effective, quite efficient. I think there's some nice flexible panels there. But we use those more often for, as I said, battery maintenance, the battery balancing process.
You mentioned back there that you can switch between an alternator between sort of when you change from lead acid to the lithium iron phosphate batteries. It's just a thing about changing the alternator or changing the charger or something like that. Is it really that simple, or am I making it overly simple? Can you just literally take out a lead acid battery?
I mean, because we work quite often, we're working with brand new boats, and one of the problems that we've encountered is that if you do things, you can change the alternator to a type that has a smart charger, but if you do that, then the engine manufacturers they get a bit upset, and you start getting into debates over warranty because you're interfering with a brand new component. So again, really to coincide with the development of lithium battery systems, electronics have been developed, and there's a bit of kit that can be included to accommodate the different charging profile. I think it's worth saying that if you took out a lead acid battery and stuck in a lithium iron phosphate without changing the alternator, it's not going to be a disaster. It's not that one is completely alien to the other, but because of the slight difference in charging profiles, it means that the lithium battery will not become fully charged at any point. And that makes a bit of nonsense of changing to something that's giving you more energy density, because if you're doing that, you want to make the most of it. And if you can't fully charge your battery, then really there's not much point in changing it. And I don't think we want to get too distracted and bogged down with the more technical stuff, but this is the profile. It's very similar to lead acid. It has an initial phase of what we call a pre-charge. This is a very small amount of current if the battery's been very deeply cycled. Very often it skips that bit. And essentially the big difference with lithium is when you're charging it, it charges at a constant current for most of the charge, for most of the time. It's when the battery gets to a slightly higher voltage that it changes to a constant voltage. And when it does that, as the voltage increases, the amount of charge current decreases. And they're very interconnected, and they're proportional, or they're related to each other. And that's what we have to have for lithium. And that's what we don't have with conventional alternator regulators. So the picture on the right shows a bit of kit. That's a 50 amp unit, and that can be connected usually between the start battery, which is connected, of course, directly to the engine alternator. And that will give us 50 amps, constant 50 amps to recharge the lithium battery. And that's generally okay. If you've got decent alternators, 150 amp alternators, that's fine. In some cases, we'll put two in parallel and take 100 amps. And they've got built into them, they look after the alternator as a priority, and they look after the alternator's primary load as a priority. In other words, they don't allow the alternator to become overheated. Because one of the problems is if you're taking a lot of current but you're only running the engine slowly, the alternator fan may not be providing enough air to cool it. So you have to make sure that it doesn't overheat.
Thank you. I mean, one of the sort of things there's all this good stuff and all that sort of thing. But one thing I think there's going to be a lot of people thinking of is what sort of costs are we talking about with regard to switching across?
Dangerous ground. So
putting you on the spot here.
Yeah, these numbers. I'm looking at what we call list prices, retail prices, what you'll see online, including VAT. you can buy a 12-volt, 100-amp-hour lithium iron phosphate battery for 400 quid. It's probably not a great bit of kit, so it's a bit dangerous to say you get what you pay for. But this is just for the purposes of making comparison. If you look at a 100-amp-hour battery with both technologies, you can see quite quickly that the one is 4 times the cost of the other, and that's the initial outlay thing that we mentioned earlier. That's normally 1.2 kilowatt hours, and we always try to work things back to kilowatt hours because it makes most sense when you're looking at load profiles. How much energy are you looking to do a certain job, and how much are you going to put back? We generally work in kilowatt hours, and it makes it easier if you're putting batteries in series. You don't have to think about things too deeply. So yeah, we always do that. So this, again, it's a really simplistic analysis, and I know that there are AGM batteries that you can discharge to 80%, but generally most of them recommend 50% as the threshold, and most lithium recommend 80%. And what happens if you stick to those figures, then you'll achieve what the manufacturers tells you to expect. So if you look at the AGM battery, you can expect with a good quality battery going to 50% depth of discharge, 500 cycles. And if we multiply all of that up, we're looking at usable capacity there. So that's the 0.5. That gives you a 0.6 kilowatt hour usable capacity. And if you do that 500 times over its lifetime, you get 300 kilowatt hours. So pretty straightforward. And that's going to cost you, again, being simplistic, taking the cost of that battery, that's going to cost you £1.25 per kilowatt hour. And if you look at the lithium, it's significantly less because of the number, A, because of the depth of discharge you can achieve, and B, because of the number of cycles you can take it through. It is simplistic, but it's just to demonstrate, back up, if you like, one of the reasons to change to lithium. If you're gonna have a boat and you're confident you're going to live long enough, then lithium's a good idea.
Oh, there is one little factor in this that it's a great presentation, but one of the things I personally experience is obviously lithium is not great in what I call sub-zero temperatures, and you've said 10 degrees, isn't it, and below, for charging, but for storage, there's an awful lot of yachties like myself who use their boats for a period of time and then never see them for 5 or 6 months. In my own personal case, I see my boat for 6 weeks in the Ionian, and then it's packed up, winterized, hope it's okay, rely on the boatyard, put a little solar panel on to try and keep my batteries topped up while I'm not there. Ask the boatyard to plug them in regularly. Now, obviously, I know when we've been talking in the past, you've got systems where you can tell what the batteries are doing, the condition of them all around the world, because you've got that connection. When you've obviously got the AGMs or the lead acids, you can't do it in quite the same way. But how do modern batteries like the lithiums cope with being left for periods of, say, 4 or 5 months without any maintenance, and the fact they've gone through a winter cycle in a UK country or elsewhere?
It's safe to say that lithium iron phosphate batteries give better performance in terms of self-discharge than lead acid. It's also fair to say that good quality AGM batteries are better than conventional wet lead acid. In my experience, the most common problem comes with what we call parasitic loads. That's where you have things like, where if people don't turn completely isolate the batteries, things like memories on electronic devices, the clock, a clock on a radio or something like that. But if you're completely isolating the batteries from the boat systems, we do have boats out there that have gone through a winter much in the way that you've talked to, because it's a pretty common thing. You know, people use their boats when the weather's good, even in the Med. So if you've got just a small amount of solar power with lithium iron phosphate, they do very, very well in maintenance terms of standing up through a few months over the winter. So if you can, and they actually really greatly benefit in terms of cell balancing from having some solar power, and you don't need a great deal. So you know, a couple of 100 watts is pretty good.
And do they need to be cycled like a lead battery? Because we haven't really discussed that. Of, you know, lead acid
No.
love being worked, don't they? They keep everything clean and working.
To some extent, but essentially, what lithium iron, and in fact, pretty much all lithium batteries really quite enjoy is being fully charged all the time.
Right.
You know, having said that, they're good for 5,000 cycles, because the best thing you can do is if you get them fully charged and you're giving them a maintenance charge and you allow them to do that cell balancing thing, and that cell balancing thing can actually take quite long periods of time, then that's the best thing you can do with them. Keep them charged. And in
So
fact,
it sounds.
if you look at, sorry, I was just going to say, if you look at batteries when they're when we've got them on the shelf and before we sell them, we actually keep them fully charged, and we have a little routine whereby if a battery's been there for a few weeks, we give it a charge. So actually, we always keep them all charged, but yeah, keep them charged.
Brilliant, thank you. And so you kind of, it's come to the time where I want to replace my batteries. I'm thinking of going down the lithium iron phosphate route. How would I go about, questions already on the slide now, how would I go about choosing an installer? How would I find someone who knows how to put one of these systems in properly?
You know, I think there's no short answer. The decent people, I mean, social media is really good, because the dealer network that we use, I know we look all the time at their social media, and we can see what they're doing. They get a good rap from the people that they work for, and I think that's the best way to go about things, is to look for people that can refer you to something, you know, where they've got testimonials. Talk to this chap. You know, my experience says actually people are generally quite connected. You know, the boating community quite likes to look after its own, and I think it's quite usual for people to get recommended anyway. But look at what they've done, what experience they have, talk to them, ask if there's any testimonies, people they can refer you to. If they're any good, they're really happy to have you do that. And the people that they've done work for are usually very happy to share their experiences. So I think there's no short answer. I don't think there's a checker trade out there for people, but yeah, you know, we have a good dealer network, and we're always very happy to put people in touch with that dealer network wherever they are in the country.
I think for me, if you start talking to different companies and seeing how much of an anorak someone is in their subject, that also gives you a fairly good clue as how good they know their subject, Paul.
Thanks, Ben. Paul, that's been fantastic. That's such a great deal of information. So well set out. Thank you very much for that. But I think it's time now to bring Ben and Peter back in. Ben, what have you got examples of what you've actually seen in real life?
Well, here we go. So this is a boat that I attended recently, and I don't think we actually need to talk about this one too much, but basically you've got almost every type of battery available on the market wired together. And I don't think there's any battery management system for the lithium on this type of battery, is there, Paul?
No.
You actually
my
couldn't
guess
believe
is
I yeah, that's what it should look like. And we go back to what we've actually got. We've actually got cranking, domestic, and a few extra batteries added on, including the lithium ones there in the bottom corner, just to give extra power.
And Peter, what would be the but what about the potential outcome of this sort of system? I don't quite know. You're on mute, Peter.
It's probably because he wants to remain speechless.
There you go. I actually said, and what could possibly go wrong? But
it's not an isolated switch. What more do you want?
Yeah, one big isolator. But and I think this is the thing. Do it yourself as all put add-ons and try and increase their capacities. Maybe with a little knowledge, they may have a lot of knowledge, but it just makes sense to call in some marine electrician or also electrician knows what they're doing. I've seen overloads on some of these cables. I've seen them bunched together in a loom where you get an overload on one of the cables because it's so well insulated within the loom, and the insulation is good at each end. It's just getting too hot inside. It can't dissipate the heat, and then it ignites all of the insulation on there. So that other picture you've got, Ben, I mean, that is a neat job, and it'd be nice if they all look like that.
Yeah, but one thing I would like to say, forget we're talking about lithium batteries. I regularly see on the inland motorway market this type of wiring.
Yeah.
And first of all, please, if you're watching and you've got anything that looks remotely, I'm sure it won't look like this, but please try and tidy up your wiring. One of the main claims I tend to go to is where negative and positive cables have been laid over each other in some way, and everyone thinks 12-volt power is not dangerous.
Mm-hmm.
But I'm sure, Peter, you know as well as I do that a discharge of a 12-volt battery is pretty spectacular when it goes.
Yeah, and that chaffing, and as you say, when they're laying across each other, they're not clipped. You get that mechanical abrasion while you're motoring along, and it doesn't take a lot. Once it shorts, it's quite a spectacular event, as you say, Ben.
Yeah. And again, the other thing is the number of times I see people wiring everything with black cable. I've actually been to fires which have been caused by someone putting a new bank of batteries on and actually accidentally putting the new negative onto the live terminal halfway through the battery group, and the spark was so intense that he couldn't actually do anything. He actually couldn't physically pull it back off the pole when it connected.
I think what we can do and see in the next slide now.
So this is
how it should be done.
Prepared earlier. Yeah.
That's what it kind of should look like.
Yeah. But I still, being a bit of a sad old person, like to see terminals covered. That's one of my only things I would do, and like bars and stuff covered, the buzz bars covered. But that's only because I've been on a couple of power boats where someone's got access to an area where they've been able to drop something down onto the connections.
And what size boat was this put on, Paul?
I think it's a 40 foot boat. It's one of our dealers, so a medium-sized boat.
So basically, that is how neat a system can look on a 40-foot boat. So
yeah, and for the guys that we deal with, that's standard work for them. I think, to be fair, they always cover the terminals. That's unfinished. I'm thinking, but I think the next picture is similar, but in a sailing boat.
Again. Oh, that's much nicer.
When a surveyor says that, it's good news there.
and again, one of the sad things I find is you have lovely big battery boxes, and when you open them up, the batteries aren't packed. with pieces of wood. And again, I've been to places where people have packed batteries and put that foam around them, which is a big no-no in any battery installation. But little packers to stop battery sliding, or choose boxes. Sometimes the boxes have those plastic dividers inside, don't they? But in a sailing yacht, they quite regularly fail. So again, if you've got battery boxes, don't be frightened to open them up and have a quick look inside, regardless of what system you got.
Brilliant advice, thanks. I'd like to thank everybody who's still with us. We've kind of passed the hour. We're coming up to the hour and a half. We finally get to the Q&A session, so we're going to go through the questions. So we will carry on. We'll answer as many questions as we can. We'll carry on for as long as there are people listening, so or people watching. So let's start with question 1. Which fire extinguishers are suitable to have on board for use with lithium batteries? Get out notwithstanding.
Well, it's a good question, because I can see a question on there about LiPo safe bags as well, and I've been looking at the current costs, and you can get one for a 12-volt battery size for less than £20. That they're really not expensive, but there's this bit of kit on here: Fire Chief Lithium Battery Fire Pack, and it contains a LiPo bag, so if it starts heating up, you can drop it in the bag, a pair of thermal protection gloves, and a Lith-X little extinguisher for that first attack, for the pricely sum of £1,131. So I suggest you get a couple of big LiPo bags that you can put them in if they're getting hot, or you're recharging them, gloves to handle them if you need to, but it's water, it's cooling them down. You know, you've got to try and cool these batteries down as quick as you can, because I haven't seen anything yet, and I'm very open-minded about how, I don't know if you, Paul or Ben, have seen anything that is better than water to tackle these fires.
I saw something at METS. I went to the Marine European Trade Show in Amsterdam last week, and I did see a product that was claiming to be for use with lithium, but I wasn't that convinced.
Yeah.
And we've generally, I think we haven't mentioned, actually, Paul, or I meant to mention, one of the things about putting lithium batteries on board is tell your insurer.
That's always an advisement. As an insurer, yes, please tell us.
But because they do want to know, and I have to say that, you know, I have spoken with the most senior people in the major UK insurance companies. They've had a little look at, in the way that we looked this evening, at some of the stuff we're doing, and what they're saying is the type of equipment we're installing, the way we're installing it, commissioning it and setting it up, they are very happy to provide insurance cover for those boats, and I think that's an important thing. But I say that because of the insurance requirements for fire extinguishing lithium aside is all that they say, if that makes sense. They don't say you need to change your standard FM200, I think I'm right in saying, Peter, is the common go-to, or its equivalents. So at the moment, there isn't a fire extinguisher that I know of. I think Peter just said the same thing, that is.
Yeah, I mean, if you look at all of
for that purpose,
fire departments around the world are using water. I mean, I've seen these fire blankets used over cars. You know, massive fire blankets. Well, that doesn't work on a boat, does it? Let's be fair. I don't think it works on a car, to be honest with you. Trapping all those volatiles under there. And I don't want to jump in, but I've just seen a question relating to this. It says, if you tell your insurer, will it increase the premium? Well, if you don't tell your insurer and something goes wrong, I think it's better to have that conversation before. Just give a different name. So
that's not my advice.
La la la. Okay,
Just say you're Peter Mansi and you'd like to know. That's the answer.
So the second, thank you very much for that, guys. I mean, the second question's coming in is, I have a new narrowboat powered by lithium batteries via an electric motor. I would like advice on how to manage my lithium battery bank to keep them in the best state and singing nicely.
I think yeah, Ben raised that, I think, when he was talking about his own boat, and I think that sort of covered it. They are described as being maintenance free in their own rights. It's all about keeping them in a good state of charge. So I would say that's the focus, is do all you can to keep them in the best state of charge at all times. But in terms of anything else, they're very happy to be left alone.
Brilliant, thank you. That was a question from Richard Kitson. Our third question is coming from Amanda McHugh. Do you recommend a hybrid system, AGM plus LiPo, lithium phosphate?
So a hybrid, was that the hybrid extension?
A hybrid system with AGM plus phosphate batteries, lithium phosphate batteries.
Yeah, I mean, if it's in the context of what I was talking about earlier, if you have a standard AGM battery pack that runs your boat's DC systems,
yeah,
and you want to add a separate lithium pack to power an inverter or a bank of inverters or something, that's a pretty standard thing to do. In terms of trying to make them work together on the same system, a bit more challenging. And I think it's maybe that's coming from this talk where I think we were talking earlier about the lithium, the extension. Yeah, which is that's what they're calling their hybrid extension battery.
Okay.
But
the thing you have to remember is the technology is changing so fast in this industry generally that there will be an answer for many of these things later, or sooner than we think.
Yeah, I mean, and so the next question coming in is, what are the advantages of having an external battery management system, BMS?
I think it provides an opportunity to interact with it a little more. I haven't really got involved in systems that do that, to be honest.
Okay.
One of the things that we like about the batteries that we use, and this applies to pretty much all of the top end batteries, better quality batteries, the built-in BMS, because it's inside the battery, it benefits from the integrity of the battery case. And most often they are at least IP65. Now, that's not to say it's a good idea to stick them underwater, because the battery terminals are only IP22. In the context, I think, of what we're talking about in terms of replacing one technology with another, I would go for decent branded off-the-shelf batteries with built-in BMS.
Cool, thank you. What are the ventilation requirements for lithium on, say, a 36-foot sailing boat?
They're pretty much like AGMs. I mean, AGMs, they do have a vent that will operate in extreme situations, generally with overcharging. Lithium iron phosphate batteries are bit of a step up from that. There is no need for ventilation in terms of gassing, but there is a need in terms of ventilation for cooling. So I would say that if they're in cases, generally that the cases are vented. If they're in a warm or in a hot area, then good ventilation.
I don't think you actually mentioned the maximum temperature they should be stored in, and certainly in the med, this year, I mean, in the Ionian where I was sailing, we were almost daily at over 40 for quite long periods.
Yeah, they will. I mean, there are two aspects to this. One is they start to derate when they get hotter, and I think that's around 45 degrees. Ideally, they need to be kept to keep them in good shape below 60 degrees. And I think that concurs pretty much with things like Recreational Craft Directive and you know, most of the standards applicable to leisure and charter. 60 degrees is the hottest you can have any surface anywhere on a boat.
Yeah.
I know it's difficult to talk about thin black surfaces in the sun at 45 degrees, but yeah, 60 degrees is really where you want to be. Again, I go back to the that hybrid extension battery. One of the things I have noticed, and one of the things that we're sort of looking into, is the recommended operating temperature for them is 15 to 20 degrees. And I think it's because they've predominantly been developed for use in power storage and non-marine applications. And I noticed in the manual that when I read it a while ago that they recommend you keep them away from water.
It's another reason why really I've experienced where batteries have exploded, not necessarily lithium, but normal domestic battery systems, where they're in engine rooms in the Med. I've actually had a couple of those happen while the boat's been running because there hasn't been mechanical air pushed in. So the whole battery bank has basically cooked itself. Yeah, so I've seen batteries explode. There's a couple on my YouTube, actually, funny enough, of batteries that have exploded while they've been in people's engine rooms in the intense heat this year. You know, and with global warming, we've got to be much more thoughtful of this because, you know, this year we've had Spain and we've got a lot of Brits out there in the Spanish waters where it was over 50 degrees. So if you're running your engine, you're just pushing even more heat into an area where many people keep their batteries.
Yep.
Very much appreciative of the fact that, Peter, I think you're heading off soon, so we've kind of overrun, I know. One last question for you, if you're happy to answer.
Yeah.
Are there any statistics out there that kind of prove that lithium phosphate batteries are at fault in the event of a fire? There's been the sort of the other product sort of side of things. I suppose there might be something about that, but what sort of statistics are we looking at?
I think it's worth, if you want to visit a website, it's Electrical Safety First, and they may have probably the best statistics, because trying to get statistics out of insurance companies is a nightmare. they don't want to share anything. But the other thing is, Paul, as I said earlier, you know, I've investigated several vessels now, and sometimes if it's easy to blame a lithium-ion battery, whether it's a toy or whether it's on board, you know, when it's burnt down to the waterline and sunk for 3 weeks and then brought back up, and you can't actually find a good bit of evidence, but they had a walkie-talkie on board that they had on charge. Well, it must have been that. And I think that's the press that they get. So you've got to be very careful. And the other thing is when fire services record something on the government statistics, that's it, it's gospel, even if it's 180 degrees wrong. So yeah, you've got to be careful. But Electrical Safety First will probably have some good information on that.
I mean that's a really fascinating point you just raised, because we're talking about all these toys, we're talking about all this stuff, and yet people have probably had rechargeable VHFs on board for years.
Well, it's just the energy density in batteries, and it's when they fail, they fail spectacularly, and that's the issue. You know, just like this double-decker bus I was telling you about, it only takes 2 batteries to fail, and the chain reaction is catastrophic, and you can't control it. And I saw one of you know, our attendees saying that you know, get out. If it's gone into thermal runaway, you're not going to stop it. All you're going to do is try and cool it down as best you can. And if it's venting off, the trouble is the toxins that come out of these batteries when they do go into thermal runaway are horrendous. they alone can knock you down and kill you, let alone when they burst into flames as well. So lots of water if you can. Get out, even better.
But we've also seen only this last week on the news while we've been preparing for this, loads of stuff about people with their vapes where they put them in the rubbish and the dust carts are catching fire in the recycling centres. So it just shows you how little damage they need before they go.
Lots of recycling centres have gone up over the years because of these batteries just being, and you know, people are told not to leave them in there, but they'll just put them in their wheelie bin and off it goes.
That's quite a scary thing. I mean, this has been one of those things. Is that there are about 70 questions. Obviously, a lot of them are repeating. I think we're going to work through a few more, but I don't think we're going to get to all of them tonight. But the next question has come in: is that our boat has existing systems that charge house and domestic and engine lead acid batteries. I'm assuming there is a dual shore charger, an engine alternator connected to a diode splitter to both battery banks, and a wind generator connected to the domestic bank only. One of the domestic batteries has failed and the other has low capacity. If possible, I would like to not touch the charging of the engine battery and minimize wiring changes. What do you think of the approach of having a split domestic system where the existing domestic charging sources connect to a lead acid battery, which then connects via a DC to DC charger to a single lithium battery, which connects to domestic loads? Sam,
This question I think I've ever heard answered. The first thing I personally would say is I regularly see faults where one battery goes down, and I know this is not lithium again. This is domestic, the normal leads and stuff. But I've always been told, even from my old father, that once one battery goes, don't try and add and swap one out. You've got to do them all. And I regularly see people who change one battery in the bank, and I don't know about you, Peter, but they change one battery in the bank, and then within 3 months, they're causing all sorts of problems with the batteries themselves. So my general advice is change the whole lot to start with. Don't mess around with trying to save something and then sort it out from there. But the question is that complicated. I think you actually need a marine electrician to go and look at it to give you the right answer personally.
Yeah, I think if that sounded, if I sort of kept up with it, I think that sounds like a fairly standard system. The more connections you make and the more devices you introduce, the more voltage you lose and the more likelihood of failure there is. So I think it's a question of going back to basics and looking for the simplest way to put that system together. So I would suggest, you know, it's worth talking to. You just gave good advice, Ben, and it sounds a bit brush off, but talk to somebody that can help. It's something that we do. We're happy to talk to people. We're not into talking to them only if they're buying. And we have a network of people that are probably best placed to answer questions like that by, as Ben says, by looking directly at it. It always bears a good looking at, even some photographs and a bit more explanation. So we'd be happy to
one of the biggest errors of every forum I've ever been on is people ask a question and expect the answer to come from the forum, where sometimes the only way to look at these things is to physically look and see what's going on, because sometimes as soon as you look, you suddenly realize there's a real problem with how it's done. Sometimes, as you've just said, overcomplicating the way something is working can sometimes be the main thing. But the biggest bit of advice is do not change the one battery, change the whole bank. Sorry, but don't pick and mix, and it's fatal.
Yeah, and to be fair, it sounds like a very plausible installation. It's a really good question, and I think it bears a good answer, but it's difficult to answer without a bit more detail. But I'm not sure of the format, Paul, but by way of people having access to us and our dealers, we're happy to talk to people and, if nothing else, give them advice, because it's always good for us in the long run to do that. So yeah,
brilliant.
have some
Next.
photographs and have a bit more question and dialogue, happy to do that.
The next one then, is there a possibility to send cell information from daily battery management system to C-zone? That sounds like pretty specific.
Sorry, I think what that was talking about interfacing data from the
battery management system, from a daily battery management system, something called C-zone.
Yeah, well, I think that's that's all part of the Navico group now. Mastervolt, I think have a connection to C-zone. They also build lithium stuff, and I know Mastervolt are very good with their interfacing. They have an interface module, and I think there are aspects of C-zone that will interconnect with the right battery data, if you like, from the right battery type.
Okay. Oh God, there's some fairly technical. I knew this was going to come. There's going to be some technical questions, but I'm going to struggle to read them. So hold on. This one. How does the panel feel about lead-acid lithium hybrid installs, where the charging remains at lead-acid profiles and the drop-in battery BMS cuts off when it is full?
Yeah, I think that's that. I think if I understand the question, I think, and again, forgive me because it's not something that I have worked very much with. I've only looked at it, but I think that's all about what's built into the battery that enables it to that function. I know there is some control via app, but I haven't looked at it in detail. But we're onto it because again, it's a burgeoning technology. I think it's interesting. It sounds very helpful. So, but not sure.
Next one. I have an electric outboard. The 12-volt charger gets extremely hot during the charging process, whereas the 240-volt charger does not. Is that normal? Ben?
Well, I don't know whose make it is, but I would always just check with the manufacturer. But Peter's gone now. But in one of his talks, he talks about when you're charging your mobile phones up, you notice them getting warm, and he always says that's a good indication that something is not right with the battery cells. But Paul, you're going to say something different, I guess.
Well, I think it's not uncommon. If you're looking at a higher voltage on the one hand and a lower voltage on the other. So if it's a 5-volt, 12-volt charger, 24-volt, I don't know, but the same amount of energy is going through both devices, but the one at higher voltage, of course, has much lower current, and they generally do not get as hot. Hard to say. If you think it's getting hotter than it should, get it checked out and make sure make sure it's compatible with the kit. Is it a manufacturer supplied item? In other words, the charger is designed and approved by the device supplier. If it is, and you think it's a problem, I would suggest talk to them.
Always check. But again, as I've said right at the start when we were talking about the toys, one of the things that I discovered was our friend was literally just taking the battery out and laying it on the deck to charge it. And what he hadn't appreciated was there was actually a stand that was meant to come with it. You meant to clip the battery on and keep it away from a surface by 2 or 3 inches to hold it in the air to charge to allow air all around it. So this thing was slowly cooking itself on the deck. So I would just double check that with the supplier that you've got everything that's correct.
Okay, next one. How can you tell if you are, this is from William Reynoldson. How can you tell if you are using too much electric on your system, hence damaging the batteries, both on lithium, AGM and lead acid?
We're back to the systems thing, I think, here. So if you are looking to provide power for a high current device, as something like a thruster, big motor, takes lots of energy, you need to make sure that the battery is rated to be able to provide that power.
Mm.
Because it's self-limiting, so you can't, if it's up to the job, you can't damage it. If there's a fault with the motor, then hopefully it's protected by a thermal device and a fuse. But I would say just make sure that the system is designed for all of the components to work together. Things like thrusters, they take a lot of energy, 400 amps, 300 amps, something like that, at 24 volts, a lot of power.
In big bursts.
Yeah, so make sure. I mean, it's where AGM batteries actually are really good. They are one of their big benefits is they have very high ability to deliver high currents, high CCA, current cranking amps, and in fact, as do lithium. And one of the benefits I've ever mentioned with lithium is constant voltage on the supply, so you don't get much voltage drop. But yeah, how can you tell if it's causing damage? It'll let you know one way or another. But I would just start by making sure the components are all compatible.
There's an interesting question here, but one for you, sort of, Ben, I would have thought. Does a lithium installation affect the value of the boat much?
Gosh, that is a really good question. Depends if anyone's watched this webinar or not. Certainly on the upper
if
end,
okay, let's just take an
certainly
example.
on the upper end markets where they've been what I call a proper installed professional system, like some of the yachts I've been involved with, where they've got the advantages of they're running a lithium bank, so they haven't got a generator, so they've really invested properly in how it's done. Yes, I do think it makes an increase in the value of the vessel, certainly. But what people have to realise is that you need to have most surveyors, like myself, I always consider myself as a GP, a general practitioner. And when you start getting into some of these small areas of boats systems where they are so technical now, you've really got to say, this is a system, it all looks very good, all looks installed correctly. What's the longevity of it? How much life is left in it? You need to get someone in to check it. Because obviously, from a value point of view, if the system is good, and as Paul has said, some of these systems, the battery systems, if look correctly maintained again every 20 years, and you've just invested all that money 3 years ago and you're selling the boat, which is one of the things I've said at the start of this, is think carefully about how long you plan to own the boat before you pour a huge amount of money, because you won't always see it back. But you need to then see what the value is and the condition of that system as to if it's going to be giving you for the next 4 or 5 years maintenance free, no cost free. Because if you have to replace a bank of, say, 4 of those 100 amp hour batteries, that's quite a bit of dosh, isn't it? So it's all going to be thought about. And again, a simple check from someone like Paul, I guess, of the system, you can tell the battery conditions to a point, I guess, can you? At least they're fault free and they're against where they are in their life cycle.
Yeah, I mean, there are some very sophisticated battery tests.
Yeah, which someone like me as a surveyor doesn't have, other than his multimeter, whereas you'll turn up and say, yes, this is great. That I think would contribute to the value of the boat.
I think if we go back to those 2 pictures, I think we saw earlier, which is the difference between a self-installation and a fresh. I think there's definitely one there that would reduce the value of the boat, and there'd be one there that would increase it. Let's put it that way. You're gonna like this one, Ben. Ross Wingwell has asked: what are the risks of self-installation of new types of batteries?
Well, I jokingly said that the best thing to do is suggest he asks British Marine, who've worked long and hard on this. And Ross will now be chuckling because he is the technical manager of British Marine. To be fair, there's been an awful lot of work on it. And I think, as Paul has hinted already, there are systems coming down the line which make it more user-friendly but the technology is very new, isn't it?
I mean, it's constantly developing. I think that's one of the last questions that's one of the last questions we're going to ask is what the future holds. But I think, yeah, it's one of the things that's always difficult from an insurer perspective is self-installation and the qualifications of the person who's installing, I suppose.
Yeah. So from an insurance point of view, I would say that even if you've self-installed it, it would be a prudent move to get someone to come along and make sure it's okay in that sense. I'm a bit loath with some of the installations I've seen which are installing approved, because as Peter before we went has said, one of the biggest problems is people sometimes mix and match components which are possibly not compatible. And I think Paul tonight has explained in an enormous amount of detail the thought that goes in to actually making a system reliable and safe.
I'm still appreciating there's quite a lot of questions together. There seems to be some adding in. Are you guys happy to carry on, or are we?
Shall we do another 5 minets?
Let's do another 5 minutes. But not one answer in 5 minutes. I don't want long answers here. All right. Okay. I'm sure other people may have asked already. I'm interested in using a hybrid lead-acid lithium system on my narrowboat. Any advice would be welcome. That's from Matt Davis.
Is that using the lead-acid hybrid?
Yeah, and yeah, interested in using a hybrid lead-acid lithium system on a narrowboat.
I think probably the reference there, I'm not sure, I might be wrong, but probably talking about lead acid for engine starting, engine cranking, and lithium for domestic. And the answer in short is yes, that's a good idea.
Yeah, and as we've said earlier, narrowboats have quite nice long roof sections where you can put loads of solar panels on, and solar panel technology is as you've said earlier, has kept up in leaps and bounds. That the panel generation is superb now. Next
one. Okay, let's go. I'm looking at charging 800 amp hour of lithium-ion batteries with two 100 amp hour Balmar 621 alternators through an MC612 dual. What protections, if any, would you advise adding, or will that charge the batteries safely? That's from Reese Cook.
I don't know for sure those alternators. I think that we're talking about standard alternators, standard regulators. So I would suggest the charge booster that we looked at to give the right charging profile, if I'm reading that right, should go in that line. Not have those. I think those are standard alternators, aren't they?
I think that's the first thing the question is. You need to check what the alternator is suitable to charge, and frankly, the manufacturers should be able to tell you what you need to put in line for their alternators.
Yeah, I think if the alternators have been for standard alternators, they've been previously charging lead acid, then you need to look at changing that charge profile via the charge boosters, DC boosters. So they will have to be added. I've just seen the Balmar 100 amp alternators through Balmar's dual regulator. I think the dual regulator, if I've got it right, that's a charge splitter. So the two alternators can both charge the same bank. I think that should have the charge splitters, the charge boosters, the DC boosters. they're made by one company and badged by lots of others. But if you look on the Victron website, they're on there, and I'm pretty sure they call them buck boosters. They do a 50 and a 100 amp, so I think they would need to be added.
Okay, and the lucky last question, Paul.
I don't know. Someone, Toby Cowan has asked, can you explain on how to calculate kilowatt hours?
In simple terms, if you look at batteries, it's pretty straightforward. If you take the nominal voltage and multiply it by the amp hours.
Nice and simple. Last quick answer.
So 100 amp hour.
That's what we like to say.
Normally, you know, it's pretty much it's a good rule of thumb. 12 times 100 is a 1.2 kilowatt hour battery. And if you're looking at load calculations, it's the same thing really. It's you multiply the voltage and the current by the time, and that gives you
guys.
That's why I never did physics.
That's why I ended up in insurance. Hey, no. Guys, huge thank you for your time this evening. I think if we could carry on for hours with all these questions, but I think we're going to sort of wrap it up now. Just a last thing from you, if I can, just in a couple of sentences, can you just give me an idea of what the future looks like in terms of power usage and all that sort of thing, energy systems?
I think a continuation of the development of battery technology. You know, we've talked quite a bit, and I can see there's been some questions about the hybrid extension. That looks interesting. Hopefully that will develop. I think the continuation of the development of lithium batteries, hopefully. And I guess we're all gagging for hydrogen and, you know, fuel development to make everything greener. So it's yeah, you know, it's been a short journey with lithium batteries. So if it continues to develop at the rate it has been, yeah, I think there's some interesting stuff coming. And just a final thing from me is you know, I do recognise that we've just skimmed and dipped into things and without great deals of explanation. And this is a very broad subject. Hopefully we've allayed some of the doubts and helped people to start to think in the right direction. But yeah, you know, there are a lot of us in the industry that are interested in this, and we really are all very keen to help. We're very keen to talk to people and help them solve their problems. So yeah,
at the end of the day, I echo your point. We are a small industry. We all come from very different backgrounds. Like myself, apprentice as a boat builder. I've been a member of British Marine for over 40 years, and the one thing I say is there are an awful lot of experts within British Marine and within the association who are keen to see us give the end users an enjoyable boating experience. But we all want to do it safely, and that's really what I've been doing for the last 8 or 9 years, is trying to make sure that people have safe, enjoyable boating. And, you know, no matter what the power technology is, we just want to see it that people enjoy themselves, not hurt themselves.
Yeah,
I think that's a really important message coming across here, is the fact that what we don't want to do is deter people from trying to do the right thing. What we want to do is make sure they do it safely, and they do it in a way that isn't going to put themselves, their boats, or anyone around them, their friends, their guests, and all that at risk. I think safety has to be the primary facet of all of this, and you know, that's what we're all after at the end of the day. But again, all I can say is Ben, Paul, and Peter, very probably on his way somewhere. A huge thank you for your expertise, your time. It's been really insightful, and I hope that everybody who's been listening in has learned a lot and now feels a lot better about, you know, the direction they can go to with regard to installing new electric systems, new systems, and even, you know, the lithium and the lithium phosphate sort of systems that are available out there now. I think huge thank you to you again, and thank you all for those of you who hung on for us for an extra half an hour. So yeah, thank you very
Take
much
care.
and good night. Take
And
care.
good night,
Thank you.
everyone. Thank you for your
Thanks.
time.
Bye, everyone.